Hello, my name is Lia Xin, and I'm honored to present my research project titled Protecting Students' Mental Health Condition Using Machine Learning Techniques. This study was conducted under the guidance and support of my supervisor, Professor Zheng Shanying. Over the next 10 minutes, I will share the backgrounds, knowledge, results, and significance of this research. In this page, we will talk about introduction, background, and research project. Students' mental health problems are becoming more serious, especially in college. Over 60% of U.S. students have reported anxiety and depressions, which hurts their studies and life. Technology now offers new ways to help. For example, the National University of Singapore uses machine learning to predict mental health risk, raising counseling use by 30%. This study aims to find the key factors like sleep and stress, create models to identify at-risk students, and help schools decide better support plans. Literature review. Machine learning is widely used in fields like psychological and machine. For example, Stanford University predicts birth risk, Changi Airports manage passengers flow with AI, and Goldman Sachs analyze stock market changes. However, using machine learning for mental health still has challenges, such as combining different types of data, real-time processing, and ensuring fairness. These studies aims to improve existing models and explore new ways to apply them in students' mental health interventions. Three methodology. This study used a Kango dataset with 27,902 records, including details like age, gender, sleep time, academic streaks, and family history. This process involved four steps: preparing data by fixing missing values and accepting key features, exploring the data to understand how features relate to mental health, building mental using six machine learning such as KNN and decision trees, and testing these models and others mystery to evaluate their performance. Exposure data analysis. We cancel the data by fixing missing parts and coding data like gender into number. From this analysis, we found academic tree and situational source strongly connect to dispersion. Sleep and study satisfaction slower dispersion. Family mental health history has a smaller effect, but it is still important. This finding help us choose the best features for modeling. 4. Model development. We test six models: KNN, logic regressions, dispersion tree, reinforced, Noe based, and the most. We use accuracy and other measures to check how they work. Adabus was the best model and with high accuracies and balanced results. Reinforced was second, while the others performed lower. This study shows how machine learning can help schools find and risk students earlier and provide support. Results and analysis. The data shows that dispersions affect 47.33% of students, while 52.67% are not dispersed, giving us a balanced dataset for fair model training. Now I will talk about the data and its connection in our study. The data looks at college students aged 20 to 30 who shows median academic streak, good grades, and medium to high study satisfaction. Its career superior students with no dispersions for those with serious patterns, showing the need for focused help. The chart shows key factors linked to dispersions. Digital slots have a strongest link, followed by academic streak and not enough sleep. On the other hand, higher study satisfactions have a negative link, meaning is may lower than chance of dispersions. This findings helps us focus the most important factors to better identify and support students at risk. Performance comparisons. Elebows has the highest sources at 86.7%, followed by Rhythm Falls at 85.4%. SVN scored 83.2%. Logic regions 81.5%, and decision trees the lowest at 79.3%. This shows Edibles is the best model for predicting depressions. The Confucian matrix was used to analyze predictions. It helps identify true positions, false positions, true negatives, and false negatives, showing the strengths and weaknesses of each model. This analysis guides improvements for better predictions. The Confucian matrix shows how well each model prediction dispersions. Random force have the most correct dispersions and the fewest missed case, but edibles handle errors more evenly. This made edibles better at avoiding mistakes and handle complex data. Edibles had the best results with 81.22% accuracy, 81.14% precision, 81.22% record, and F1 scores of 81.30%. Logical researchers and Raiden Falls was close, but KN and Distinction Trip and Loewe scored below 80% because its high accuracy and ability to handle errors and complex data. Edible is the best model predicting students' dispersion. 6. Discussions. This study used 6 machine learning models to predict students' depressions, with Edibles being the best. The main features include digital stop, academic pressures, study satisfaction, sleep, and family history of mental illness. This finding can help create better mental health support. However, this study has some limits. The data was small, with not enough variety, and it didn't include predictors like social interactions, mystery like AUC and ROC, which give deeper insights, were also not used. Features like CGPA and age, which may have complex connections, were left out. The way of the data was processed may have affected the results. The age range of the students was narrowed, making it harder to apply the finding to a larger group. Future studies should use bigger datasets with more varieties, including social and behavior data. By adding better features engineering, real-time use, and more detailed resolutions, future research can improve the accuracy and usefulness of those models. Even with its limits, this study shows machine learning potentials to improve mental health support for students. 7. Conclusion. This study focus on using machine learning to predict student dispersions and highlight edibles as the most effective model. It shows how special features like academic history, digital source, sleep patterns, and family mental health history are the keys is identified at-risk students. These insights underline the importance of target support street to improve students' well-being. However, there is room for improvement. Future research should focus on expanding data research and include social and behavioral partner, academic terms, and physical health interactions. Adding these features can help create a more complete understanding of students' mental health. Long-term studies are also critical. They are mental change over time and assess how interventions work in long run. For example, finding the relationships between history and sleep suit experiments can get better solutions for students. And another area for research is creating personalities productions model. These models can consider individuals' difference to provide more predictions and inference interactions, cooperations among researchers and educators will also be keys to building stronger systems. Finally, protecting students' data through strict privacy measures is efficient. As we rely more on machine learning for systems issues like mental health, considerations must remain a top priority. This study is a step forward, but there is much more explored and improved better real-world results.